Excellent. So last time we went over the syllabus, we talked about some of the course goals a bit. We talked a little bit about efficiency of algorithms and how we could determine whether something was efficient or not using the dirty room or clean room example of some operations were easier in a dirty room, some operations were easier in a clean room. We talked about the concept of abstract data types. This idea of basically you have an interface that defines what a data structure can do, but we don't talk about the implementation of that data structure. It's just a matter of what does it do. And so we tied that to the 211 concept of interfaces. So the goal today is going to be to get started writing the linked list with generics from scratch, and we'll finish this off over the next couple of class periods. But I want to start to talk about how do we, rather than coding to an API, how do we start designing our own code from scratch? How do we think about the design? How do we go about that implementation? What do we need to consider? One of the big issues that I see with novice programmers is that they hop into the code way too quickly. They have a generic idea of what they want to do, and you will start programming and realize partway through, oh no, this is not actually what I wanted to do. And it's easier to start from scratch than it is to fix the spaghetti code that you've written at that point to go back and adhere to the specifications. And that leads to people don't like starting over from scratch. It feels like you're erasing progress. And then you end up taking way more time than it would otherwise take with some basic planning before you get started to end up with the finished product. If you've ever experienced I spent 10% of my time coding and 90% of my time debugging, this is what I'm talking about. I had this happen to me all throughout my undergrad. It just happens. It's something that you have to learn and overcome, that there's a significant design segment to any reasonably sized programming. So let's start by, I just want to basically introduce the concept of generics for those who it's been a little while or who haven't seen it before. So who here has, I guess let's start with a series of thumbs to tell me how well you understand this or don't understand this. It helps me just to get a sense of where the class is with regards to your understanding of particular concepts. So if I talk about Java generics, how do you feel about generics? Do you feel like you understand them really well and know how to implement them? Do you feel like, oh, I kind of understand them at a basic level, but I don't know if I could implement them, or I have not heard of them, or I've heard of them, but I don't really know what they do? All of those are perfectly fine. It just gives me a sense of the level of detail that I should go into as I do it. Excellent. So generics are a struggle point. That's good because they're not the easiest topic. So we'll start kind of from the ground up and do it in a little bit more detail. So we've all made array lists before, yes? In an array list, we put something inside of the angle brackets. So we have something like array list, angle bracket, something equals new array list, angle bracket, something. What is that something? Class. Some data type of some kind? Yeah, the idea is that there's an array list of that type. So here's an example where type can be filled with any data type. So what do we think is happening here? Just take a stab in the dark if you have no idea, but what do we think happens with this type? If someone could try to explain this in a way that makes sense, how does it make sense to you? Yeah.
The array list is set up with basically just a placeholder. So when you put the type in there, it fills it in.
Yeah, that's exactly what's happening. So the question that I would ask people would be something like, do you think that there is separate array list code for each possible data type? Is there an array list class that works with integers, and an array list class that works with doubles, and an array list class that works with strings, and an array list class that works with any other data type that you could think of? The answer is, that would suck. That's a lot of code to write, and it's probably almost exactly the same code over and over and over and over again. So that's the reason why generics exist. We need some way of saying, we don't know at compile time when we're actually going to go click the play button on an IDE to say, run this code. When we actually go to compile the program to determine, is this legal Java or not? We don't know what kind of array list we're going to be making yet. We need to have the ability to, during the program's execution, fill this with the appropriate type, be that an integer, be that a double, be that a string, be that a custom class that you make. So objects that you create and define in your own code still need to work with this array list code. So we need to have some way of defining a type as an, we don't know what this is yet, but we're going to figure it out during the runtime of the program. Someone will tell us what to instantiate this with. When you say array list integer list equals new array list integer, being the wrapper class for the primitive int, then we know when they make that list, okay, this list is going to contain integers. Does that make sense? Questions about that concept? We can't do things like store a double in an array list of type integer. Once we define an array list of type integer, the name list is associated with array list of type integer. So you can't add a double to an array list of type integer because it's been defined to only work with type integer. You could make an array list double list 2 that would then be associated with the double type. But once you make that binding at runtime, then it is locked in place. So what do? We need some kind of generic placeholder. So in general, we use either T, capital T, or capital E. We'll have some kind of decision to make as to whether we use T or E. Usually capital T is more of the C++ style of syntax, and capital E is generally the Java style of syntax. But it can go really either way. It doesn't matter. The compiler doesn't care what we use here. But wherever we see a T or an E, it just represents whatever type is between those angle brackets that we defined when we made the array list. Questions? All right, so we are going to code a linked list generic from scratch, which will be good because maybe I can get you all to tell me what exactly did you do in 211? I know you had 3 labs related to linked lists, so you've seen them a lot before, but how was that modeled in class? Did you write a linked list from scratch, or did you kind of throw that together as part of your labs?
Part of the lab, yeah, like base, like Apple code kind of.
Yeah. So it might be good to see when we start with a completely blank file, how do we actually design a linked list? How do we actually go about thinking about it and designing it from the ground up? I think that's especially useful because linked lists will appear a lot on the 8. And it's something that you're going to want to be able to know through and through. So I don't feel too bad, even if you feel like you have quite a history with linked lists. I don't feel too bad going and doing it again just to solidify it, to make sure that it's as clear as it can be, because that will absolutely help you on the 8. So let's start with some design questions. If we want to make a generic linked list, the first thing we should think about is, okay, what fields and what methods do we need? So let's start with the fields. What does a linked list need in order to work? And I'm not yet specifying what kind of linked list we're making. I'm not specifying if it's a singly linked list, a doubly linked list, a circular linked list with or without a head.
You build the data example.
Yeah, so we need some kind of type. It's going to hold something. Each node has a value associated with it. What else?
The subclass for every node.
Yeah, we need some way of specifying what a node object is. Did we see that modeled as a separate class or as an inner class? Have people seen inner classes before?
There's an inner class.
We'll probably do the same thing here, or I might start it as an outer class and then move it into inner class. So we need some kind of data. What type is that data going to be?
Generic.
Yeah, some kind of generic, either the T or the E, whatever we decide. We'll probably just go with T because it's straightforward. Inside of the node class, what else do we need? So this is thinking about the node class.
Index pointer.
Yeah, we need some kind of next. What data type is the next? The node. Great, so that'll be good for that. We also need to potentially store a head or a tail, depending on if we're going to have a tail pointer as well. Thinking about the methods, what behavior do we want to be able to support in a linked list? So what do we want to be able to do to a linked list?
Adding, deleting, inserting.
Yeah, so we need to be able to add. What kinds of parameters and what kind of return do we expect with add? So a parameter, we need to know what we're going to add to the list, right? So what data type is that going to be?
Generic.
Some kind of generic, whatever we happen to define it to be. Is add overloaded? Are there multiple different kinds of add? Yeah. What were those different kinds of add?
Add to the front or add all.
Okay, yeah, we could do an add all. Probably won't do the add all, but we can do an add at the end of the list or an add at a particular index that allows you to specify where in the list you'd like to place the new item. And that way you could just, if you wanted to do an add all, you could just throw it into a loop in the client code. How about remove? You want to be able to take things out of the list. So we need to know what index. What does it return? Generic data type, yeah, something, it tells you what was removed from the list. How about get?
Index again.
Yep, it's basically the same thing, except we don't actually remove it from the list. We also need a size. We need some kind of either toString or print nodes or some kind of ability to see what's in the list. One other thing to think about is what kinds of exceptions should each of these throw? Did we see exceptions in 211?
Yeah.
So what kinds of exceptions do we expect each of these methods? How can they go wrong? Index out of bounds for which ones?
For remove,
Definitely for remove.
get,
Sounds good. What other kinds of exceptions might we expect?
Illegal argument.
Illegal argument exception? In which?
Add.
Add, yeah. Sure, if you put in the wrong type. So let's get started. We've started to think about this. We probably actually want to write all of these things out with their associated types, but that's what the interface is going to be for. Even though we're only going to make one kind of list, I would always start with some kind of interface because we may end up writing an extra list type in the future. We probably won't in this class, but it's good to just use that as a brainstorming. So let's actually go do it. So as I mentioned before, I'm in Eclipse, but it's the same basically through all IDEs. There's not going to be a ton of difference between this and IntelliJ or any other IDE that you may want to use. So I just have a project that we're going to use for everything that we make in this class. Inside the source folder, we're going to have packages that represent everything that we do. So we will make all of the different kinds of linked lists that we make inside of this package, as well as the interface that we're about to write. When we move on to different data structures, I will just throw them in a separate package for that particular data structure. And that will be the package structure, and then I'll upload anything that we do to Canvas as well. So when you select new, you usually have an option for some kind of interface. We're going to start with the interface. We're going to call it list of T. And in the name, you want to specify the kind that it is. If it's going to be generic, you want to make sure that it's there in the name. Is there anything that we should do to this list, while we have it? And the answer is yes, but I don't know if we're going to quite know what this is yet. Have we seen the concept of iterable or iterators? Looks like no. All right, we're going to come back to that then. We will come back and edit this to talk about exactly how to do this, because there can be some issues as you loop through to do something if you want to modify it while you do it. And I'll talk about this after we finish putting it together. So let's start with adding at the end of a list. What does that look like in its interface form? So remember that when you're coding to an interface, you don't specify any implementation. You're just giving method headers. Basically, you're going to have the return type, the name of the function, and a list of parameters. And that's it, no implementation. So maybe I'll write the first one just so that we know. So add is going to return either true, it was successful at adding the node, or false, it was not successful at doing so. So it's going to be a Boolean, we'll call it add, and it's going to take something that we're going to call an element. And we talked before, the type that this is going to be is of type T, the generic type. We did mention that it might throw an exception. When we add at the end of the list, the only exception that we might expect would be a null pointer exception. So just as before, in your interfaces, I can blow this up so it's a little more visible. You want to make sure that you add your throws clauses to your interface to make sure that when you go write them, the interface knows to expect it as well. So that's the general syntax that you're going to want for any line of an interface. We can do the same thing for adding at a particular element, at a particular, sorry, not at a particular index. What would that call look like? Start with the return type.
Yeah, it would probably be the same as that
Same?
additional parameter for the index.
Yeah. So we want to have, we will throw the index first and then the element second. Why not? And then does this throw any exceptions?
Index out of that.
It's going to throw null pointer as well. And it's going to throw an illegal argument. And if we end up with an add that is out of bounds, it's because the argument was not what it should be. So you could really use either one there, either an index out of bounds exception or an illegal argument exception. I'm going to do the illegal argument. And if you have multiple exceptions, just comma separate them. That'll make sure that it gets done. All right. Let's do get next. What should get look like? What's the return type? T. Parameter list. That should be everything we need to get something, right? All right, what should it throw? That would be a reasonable one. I'm gonna do an index out of bounds here. It often doesn't matter the exact exception that you use, that would be perfectly valid. How about remove? So it's gonna return the same thing, right? If we're removing something. So we need to make sure we have an index for that. And that will also throw an index out of bounds for that. All right. We're also going to overload remove to also allow us to be able to remove a particular element if that element is in the list. So if this were storing something like integers, we could say remove the first instance of 17 from the list. So if we did something like that, we want to determine if it's possible to do so. So it's going to be a Boolean. We will call this remove. And that is also going to take the element that we want to remove. If we do this, we're going to throw an illegal access exception. We'll see what that does momentarily. And finally, we're going to have some kind of update that is going to allow us to make a change to a particular index to replace what is at that index with something else. So that will return whether or not it was successful. We'll call this update. It'll take an index and the element we want to replace it with. And that will just throw an index out of bounds. All right. Last couple things we need to figure out how big the linked list is. So we're just going to have size and is empty. Neither of those can throw exceptions. They should always work. So this is it. This is the entirety of our interface. Questions about the plan functionality? I like to do all of this work before I get started coding, because this allows me to kind of throw this, if I have two monitors, which I don't have here, it's really annoying. I would throw the interface up on one screen and I would throw the code up on the other, and I would make sure that I'm coding to the interface. And this is the planning phase of our project. We just have basically decided that, all right, this is what we're going to implement. You can critically think about, is this all of the functionality that I need? Are these the associated exceptions that I'm going to throw? Are the parameter lists what I expect to give to each of these methods? Are the return types appropriate? You do all of that thinking before you get started. So that's just the interface. Let's get started with the code. So we're going to go make a class that we will call linked list. That's all we want. Let's go ahead and get started. This actually should be linked list T. Note that you don't have to refactor. If you do something like add the T to the end, it doesn't actually affect the name of anything that's in angle brackets. Normally, if you were to change something like this, you'd have to sort of like right click, go down to refactor, and then you'd rename the name of it. But if you just made a mistake by forgetting the generic at the end, you do not need to refactor that, because you can see here on the left that the list that I wrote here was list of T, but it doesn't show up in the name at all. So that doesn't matter. So let's actually get started. Let's make. Do we want to get started with the linked list, or do we want to get started with the node? Let's probably get started with the node. I'm actually going to make this in a separate class so that we have access to it, and then we can talk about how to turn this into the inner class if we want to. So we're going to make this a node, and node should also be of type T. All right, when we're thinking about the node, what do we care about? What are we first going to do? What are the fields that we should write? Some kind of data, some kind of node that has to be of type T. That's going to be the next pointer. Great. Those are our two fields. We need some kind of constructor. What is the constructor going to look like? So this is without a dummy head. That's fine. Well, we'll do that in the linked list. Maybe we want a couple different kinds of constructors. What would those constructors look like? What do we want them to do?
Do one that just takes type data and then sets next to null or.
Yeah, that's exactly what we want. So we're gonna have a node constructor that's going to take the data, it's gonna be the generic type. And inside of this constructor, we want to set data. It's the same name, we need to use this. We're familiar with the keyword this from 211. We've all seen this before when we have a parameter, sorry, when we have a field that has the same name as a parameter, we need to use this dot data to refer to the field. So we're setting the field equal to the parameter. And then we also want to set next to null because we don't have anything to set next to. This would be for the first node that we add to our list. We can have an overloaded constructor that takes two things. It will take the data and it will also take a node, and that needs to be generic. We can then set so now we have two different ways to make nodes. We can either make the first node in the list that sets the next pointer to null, or we can make a middle node that we also pass it the next, which allows us to do things like insert them into the middle of the linked list. Is there anything else that goes in the node class? We could do header tail. That's probably going to go in something like the linked list if we want to do that. It doesn't actually have anything to do with the nodes creation or the node structure, but that is an excellent point. It is something that we need to consider whether we're going to use a head or tail. So this is it. This is the entirety of the node class. Significantly easier than the linked list class is going to be. But this allows us to have a structure that represents a node. If we want to do something like draw out what this is going to look like for us, you can think of the fields that are here. We have a data and we have a next. So this is going to be represented visually as some structure that is split in the middle. Inside of here, we're going to have a data. Inside of here, we're going to have a next. And the data is something of type T. And we're just going to fill with whatever we pass in. Note that regardless of which constructor we call, we're always passing in that data. And in this case, there's going to be a next. either the next is going to be null, which just says that it does not point to anything. Or that next is actually going to point to another node object where we have some data. And we have a next that actually points to another structure. So these are the two different ways that we can construct a node. We're gonna make a node that says the next points to some other structure that we're passing in, or it is nothing. Have we talked about the concept of null and null pointer exceptions and what those actually mean in memory, kind of reference semantics? Somewhat. So the basic concept is that you have an object, and when we make this object, it's really just a reference to something that is in memory. When we actually make this node and return it, what we actually have is a reference to that object. If we call this like node, let's say we have something called head. The way that this is under the hood stored in memory is this is an actual reference to a node object that is stored elsewhere. So this is why when you say something like head dot data, that dot is a dereference that follows this arrow to the object. And this, the purpose of this object is just to tell you where in memory this object is located. You can think of it kind of like my sitting here and pointing right there. That's where it's stored. I'm not actually storing anything except where the thing that I care about is located. The thing that I care about is over there. So that whenever you make a variable that represents some complex object, that's really what you're doing. You're making a pointer to where this is actually stored in there. Whenever you have that, you need to say dot something, which is why you get a null pointer exception if you have something like this. If this does not lead to an object and it leads off into nowhere, when you say head dot data, it's not pointing at an object, it's pointing at nothing. You can imagine if I said, all right, if I point at you, answer the question 1 + 1, ready, go. Utter silence because I'm not pointing at a student. If I'm not pointing at someone, I'm not going to get something back. So if you try to say something like, whatever head is pointed at, return your data, that object doesn't exist. So what the computer has to do is throw a null pointer exception because this pointer is pointing at null, it's pointing at nothing. So that's the basic why behind dereferencing and null pointers and. I was saying that there not being an eraser here yesterday, so I brought one. Which will eventually come out of its package. Sort of being in the process. Questions on any of that logic or why that works? All right, so we have the node class complete. So now we can start going into the linked list class and start implementing that. So this should work. Normally what I would do at this point, if I were doing this not based off of a reference, but actually coding this myself, is I'd want to go test it and make sure that it works in some kind of client program. So I would go make a driver or a main or something, and I would go make some nodes and see if I can actually construct nodes that make sense. If I could do this, then I would know that this works. I will just tell you now that this works. But if I'm doing this myself, I'm stopping at this point and making sure that nodes work before I move on. You do not want to make too many changes to your code before you test it, because if you've done this entire project without testing it at all, how many things could go wrong? So many of them. If something does go wrong, I have a large task ahead of myself to try to figure out what that is. Where did it go wrong? There might be 5 things going wrong, where the first thing that goes wrong affects the second thing that goes wrong, affects the third thing that goes wrong. And it's really difficult to figure that out. It is always worth the time to do a gut check test. If you're just writing something like this, as soon as you have a method complete, test it. As soon as you have a basic object like a node complete, test it. Make sure that it works in its very default cases. All right, back in the linked list, let's actually go figure this out. So we need to figure out what fields we're going to have. What fields does a linked list have? It has some kind of node that represents what? The head? Yeah. So we want to make sure we have. And now since we're in an object that we don't necessarily want outside access for, we should probably put some access modifiers on these fields to make sure that they can't just arbitrarily be changed. So we want to make sure that everything that goes inside of this linked list is private. All right, we'll make a head. I am not gonna make a tail because linked lists don't necessarily have them, and it's good to know the pros and cons of having a tail or not having a tail. We'll talk about that as part of our trade-off analysis when we finish the linked list. So we have a head. What other fields are we gonna want? Size. We need to make sure that we have a size. Yep. Is there anything else we're gonna want? I'm gonna store something that's gonna be a little bit interesting. I'm going to store what we're gonna call a current. And that's going to be if we're gonna do any iteration through this or anything, it'll be whatever node we're currently looking at. So we'll just have a current node. Great. How do we construct a linked list? Are we storing an array inside of the linked list? Yeah, you're good. Yeah,
We just need to make constructor and set the head to whatever the data type pass through is.
we actually get default constructors. So you can actually do something like nothing and it sets everything to null. Is there any reason that we would want to change any of these values? Like maybe set size to 0? But it's kind of okay if head and current are no, we might as well just say it. Head is no. Excellent. There's one other thing that I forgot to do that's kind of important. Can anyone see of everything that I've done so far, what have I missed?
To implement the,
Yes. Back up in the class header, I need to make sure that I implement the. That'll go away once we make sure we have everything from the implements. So we need to make sure that we take our interface here and we actually link it to the linked list so that we ensure that we have implementations for everything here. So it's perfectly okay for this to be squigglied until we have the implementations of all of the methods that we said we were going to implement in the interface. All right, so now it's time to start getting started on the add methods. So let's actually get started with that. What should I type first before I even start thinking about the actual methods? There's an important thing that goes before the method. Yeah?
Add override.
Yes. I'm gonna make sure we override. So the override here is very important. This tells us that we are actually implementing the interfaces add here. So it's going to expect, one, that we return a Boolean, and two, that we throw somewhere a null pointer exception. All right, how do we add to a linked list? A little bit of a process, right? Let's first think about what can go wrong. So why would we throw this null pointer exception? Yeah, if we pass in an element and the element is null, we don't want to add null to our list. That wouldn't go so well. Great, so we're going to check it. We're going to say if element is null, then we want to throw the null pointer exception. And we should probably print something to the screen as we do this. Let's say throw new null pointer exception that says, I don't know. Parameter is null. Great. And for small ifs like this that just exist to throw a null pointer exception, I don't throw curly braces around them because there's no reason to go back to them again. Normally I do. I always think that curly braces are better, but if you're doing a small thing like throwing an exception, it's not too bad to leave off the curly braces. We're familiar with what happens if you add or don't add curly braces in an if statement. So if you don't have curly braces, you're only allowed one statement. That one statement is inside the if. If you don't do that, if you have curly braces, you can have an arbitrary number of statements inside the if. So since there's only one statement here, throw this null pointer exception, we don't need the curly braces. All right, so if it's null, we throw the null pointer exception. What else do we need to check?
Size 0.
Yeah. Yeah, if the size is 0, then we need to basically do some different logic depending on if this is the first element that we are adding to the list, or if it is not the first element that we're adding to the list. So the easiest way to say if size is 0, we're going to implement a function for this called isEmpty. So we can just call isEmpty. And we might as well write isEmpty at this stage because that's kind of important, but note that the compiler doesn't care about isEmpty. Why is it not complaining about isEmpty? There's no implementation for isEmpty. Yeah, there's an interface that says that we're going to implement it. So it actually is not going to tell us here, this red squiggly will not go away until we've implemented an isEmpty. So it's not going to double tell us that there's the same issue. It's just going to give it to you here instead of here. Cool, so if it is empty, if this is the first thing that we're doing, what do we want to do? Where are we going to be inserting this? What is it? Yeah,
We insert it like at the head, right?
yeah, it's going to be the head of the list. We could do it that way, so we can say. Actually, don't see here. So that's how we do that. we said that we make a new node object and we associate that node object with the head. And the reason this works, we talked about memory diagrams before. Remember that. This is fine, only have 4 minutes left in class. This is every day. So annoying. Now you can't snooze it because it's under 15 minutes. Great. Evil. So we talked about memory diagrams. Right now, we have this concept of head that is pointing off to nothing. Basically, what we're doing is we're making a new node object. We're assigning it with this element that we're going to make this. So new node, passing it element. So this is going to be whatever elements happen to be. And the next, when we did this, was null. So this is going to point off here. And we're just basically saying associate the head with this object. So instead of this pointing off to nothing, now this is going to point off to this object that we just made. So when we refer to head, now we're referring to this new object that we just made. Let's see if we can finish this off with the last 3 minutes of class. So if it's empty, we want to set the head. We're going to do something here that will make sense in a second. We've added a new node, so we need to bump up size. And we were successful. So we're going to return true that we successfully added this element to the linked list. So that's how we're going to handle it if this is empty. If it's not empty, what do we want to do? That means that there is an existing, at least one existing node in our linked list. Yeah. So we're going to first make the node. So we're going to just do exactly this, except we're not going to call it the head. We're going to say that we want, I don't know, what do we want to call this? So we'll do that. So what's nice about current, the idea of current is it's going to store the last place that we need it to be. So we can just basically say that wherever we are in this process, when we call this add, we're going to be setting current to basically be where we need it to be. So we can use this concept of current to not have to iterate through the linked list. So we're going to say current dot next is the node that we just made. We will then bump current to be that. Bump up the size. And return true. And that's the first add. We will come back and probably get a chance to finish off this whole thing next time. Does anyone have any questions for me real quick before we end class? Does this all seem familiar or make sense as to what we're doing and why we're doing it?
So with your constructor where you set the parameters, would there be an issue with just initializing the those values as null and 0 and null?
Yeah, we're gonna come back to that. Okay, there is an issue with that. Okay. All right, have a good day. I will see you bright and early tomorrow morning.
Great, how'd you end up finishing up school? I just, well, I know, I was in spring, I just saw it. Like, once- You are like a.
Cool. No bugs.
It's a win, that's not fly like objects should.
Get ready to move back like that.